Hello dear students of 9th class, respected teachers. So today I am going to discuss chapter 11th of science, which belongs to physics, and the name of chapter is sound. First of all, what is sound? Sound is a kind of energy that produces sensation of hearing in our ears. It is produced by humans, birds, bells, vehicles, TV, radio, machines, any vibrating body. All are the sources of sound. How it is propagated? We take simple example of a tuning fork. This is made up of metal. These are two prongs of tuning fork, and this is known as stem of tuning fork. When prong of tuning fork is allowed to strike on a rubber pad, the tuning fork is set into vibrations. Both the prongs, they start vibrating like this, shown by dotted lines. Now when this tuning fork vibrates, surrounding air particles gets disturbed. They also start vibrating. Then suppose this particle is disturbed, next particle is also disturbed. In other words, this vibrating tuning fork forces the surrounding particles to vibrate about their mean positions. So why they turn to their mean positions? Because of property of inertia and elasticity. So each and every particle starts vibrating about its mean position, and energy is being handed over from particle to particle. So at certain regions, when the particles are close during their vibrations, density increases, pressure increases. As a result, this is known as compression. At certain other region, when particles are far apart, density decreases and hence pressure also decreases. So this is called rarefaction. So this happens at regular intervals. So large number of compression and rarefactions are produced. So this is how sound wave propagates through medium in the form of compressions and rarefactions. And distance between two consecutive compressions is known as one wavelength, or distance between two consecutive rarefactions is also called one wavelength. So this is a wave, and such a wave is called longitudinal waves. Why longitudinal? Because particles of the medium vibrate about their mean positions in the same direction as that of propagation of the wave. So wave is traveling from left to right. So particles also vibrate on the line like this about their mean positions. That's why sound waves are longitudinal in nature. They travel in the form of compressions and rarefactions. Distance between two consecutive compressions or consecutive rarefactions is known as wavelength. Then some characteristics of sound. Frequency. Number of vibrations per second is called frequency nu. Time taken to complete one vibration is called time period, capital T. So if V is the velocity with which wave, that is sound wave, propagates through the medium, so V will be equal to distance traveled by upon time taken. So during one time period, one compression or rarefaction is produced. So distance called will be lambda. So lambda upon T. So 1 by T is called nu. So V is equal to nu lambda. So velocity is equal to product of frequency and wavelength. So this shows that velocity of sound is same for all frequencies for a given medium and under similar conditions of temperature and pressure. And this condition is true for all types of waves, whether longitudinal or transverse. Whether it's light wave, so V is equal to u lambda is true everywhere. Now, factors upon which velocity of sound depends. Velocity of sound formula is given by V is equal to under root E by rho. Because sound can travel solids, liquids and gases. Means sound is a mechanical wave. It requires material media to travel. So sound cannot travel in vacuum. So if E is the elastic constant of the medium, solid, liquid or gas. Rho is the density of the medium. Then velocity is given by under root E by rho. So derivation is not in your syllabus of this expression. So this you will derive in +1. So or it can be proved it is gamma P upon rho. P is pressure, rho is density. Gamma is ratio of specific heats. Gamma is a constant. Its value for dry air is 1.4. Or you can say it is gamma RT upon M. Gamma is again constant. R is a gas constant. T is the temperature on absolute scale. M is the molecular weight. So from this equation we can study all the factors upon which velocity of sound depends. Number 1, effect of density. So from this, when we study effect of density, all other factors are kept constant. So that is for a given medium of density rho, V is inversely proportional to square root of density. It means velocity of sound is more in a medium having less density. Velocity of sound increases with the decrease of density of the medium. That's why velocity of sound in hydrogen is more than the velocity of sound in oxygen, because hydrogen is lighter than that of oxygen. In other words, density of hydrogen less than that of oxygen. If you calculate, velocity of sound in hydrogen is about 4 times the velocity of sound in oxygen. 4 गुना होती है. Second, humidity. In the presence of humidity, that is moisture, density decreases, because density of water vapor is less than that of density of dry air. So in the presence of moisture, density of air decreases. So therefore velocity increases. That's why sound travels faster on a rainy day than on a dry day. The question may be asked, why sound travels faster on a rainy day than on a dry day? Because density decreases in the presence of moisture, that is water vapors. Third, effect of temperature. Velocity of sound is directly proportional to square root of temperature on absolute scale. It is more the temperature, more is the velocity of sound. It is velocity of sound increases with the increase of temperature. That's why sound travels faster on a hot day than on a cold day. Fourth, effect of pressure. From this equation, if temperature is kept constant, R and M is constant, velocity is independent of pressure. So velocity of sound is independent of pressure provided temperature is constant. Then effect of wind velocity. So wind velocity affects the velocity of sound. When sound is traveling in the same direction as that of wind is blowing, velocity increases, and vice versa. If we listen the sound in the direction opposite to the wind velocity, its velocity will be less. Amplitude. In general, velocity of sound is independent of amplitude, provided it is small. But when amplitude is large, then it affects the velocity of sound. Velocity of sound increases with the increase of amplitude when it is large. But when amplitude is small, it is almost independent. For example, when you pluck the wire of a guitar, the small amplitude velocity is small. When you pluck it strongly, the strong force with more amplitude, its velocity will be more. So velocity is affected when amplitude is large only by a slight amount. So all these are the factors upon which velocity of sound depends. And we have already said velocity of sound is same for all frequencies provided medium is same and physical conditions are same. That reflection of sound. Sound obeys the laws of reflection as that of light. That is, when sound strikes on a hard and smooth surface, it is reflected back into the same medium. This can be proved by simple experiment. We take PQ as the hard and smooth surface, because for reflection smooth surface is needed. And suppose we put a watch or timepiece here and we observe the sound on other side at same angle, you will hear maximum intensity of sound of watch when I is equal to R. That is, sound is reflected as light waves. It obeys the laws of reflection. What are the laws of reflection? Number one, incident wave, reflected wave, and normal. Or you can say incident sound, direction of incident sound, reflected sound, and normal all lie in the same plane. Second, angle of incidence is equal to angle of reflection. I is equal to R. So these are two laws of reflection. Reflection of sound has so many applications. From reflection of sound, we define what is echo. Because when sound strikes at some large obstacle, mountain, hill, or even in a big auditorium, big hall, when we speak, we listen, the repetition of sound, that is called echo. So echo is the repetition of original sound. Echo means the repetition of original sound due to reflection of sound is called echo. Now, when we see echo, sensation of sound permits, sensation of sound persists in our brain for about 0.1 second. Because when we receive a sound, it persists in our brain for about 0.1 second. It means if V, velocity of sound, is 344 meter per second, because velocity of sound depends on temperature. So at 22 degree Celsius, its value is 344 meter per second. At 0 degree Celsius, the velocity of sound is taken to be 332 meter per second. So 0 degree velocity of sound 332 meter per second ਹੁੰਦੀ ਹੈ ਤੇ ਜਦੋਂ temperature ਵੱਧਦਾ ਹੈ ਤਾਂ velocity ਵੱਧਦੀ ਹੈ. At 22 degree, velocity of sound is found to be 344 meter per second. And suppose at normal temperature, V is equal to 344 meter per second, and it should time during which sound persists in our brain is 0.1 second. Now we want to hear echo of the original sound. So it should come at least after 0.1 second after the original source is switched off. जैसे original source बंद हो चुका है, उस तो बाद साडे कोल जे 0.1 second तो बाद sound आएगी तो सानू ओदी echo distinctly सुनाई देगी. We can differentiate between original sound and echo. Otherwise we cannot differentiate if it comes earlier than this 0.1 second. Because sensation of sound persists in our brain for about 0.1 second. So when we speak, sound goes to an obstacle, then gets reflected from the obstacle, comes back. It means it travels distance twice between the source of sound and obstacle. Suppose distance is d. So when we receive reflected sound, it will travel twice the distance with the velocity 344 meter per second, and time should be at least 0.1 second to differentiate between original sound and echo. So if we calculate the minimum possible distance of obstacle to hear echo, it should be 344 into 0.1, that is velocity into time, total distance divided by 2, because it travels twice the distance between source of sound and the obstacle. So it comes out to 17.2 meter. So just to remember, what should be the minimum distance of an obstacle to hear its echo of the original sound? It should be at least 17 meter. That is, we observe echoes in a big hall, big auditorium, not in small rooms. So if distance is 17 meter of the obstacle, say mountain, we are standing in hill area and we make a noise. The mountains are far away, so you will receive its echo after some time. So you have to remember this. The distance between the source of sound and obstacle should be at least 17 meter to hear echo of the original sound. Then what do you mean by reverberation? This phenomenon of reflection of sound causes reverberation. In a big hall or an auditorium, multiple reflection takes place. When source of sound is switched on, sound is produced, multiple reflection takes place. And due to multiple reflection, so many echoes are produced. So which mix with each other, so due to which quality of sound is not good. So because our sound persists for some time even after the source is switched off due to reflection of sound from various surfaces. This phenomenon is known as reverberation. The phenomenon of persistence of sound for some time in big hall or auditorium due to multiple reflections of sound from various surfaces is called reverberation. And to make a sound of good quality in an auditorium or hall, we have to control the reverberation time. So reverberation time is the time during which the sound becomes inaudible after the source is switched off. Suppose ਅਸੀਂ ਕੁਝ ਬੋਲਿਆ ਹਾਲ ਦੇ ਵਿੱਚ, ਬੋਲ ਕੇ ਨਾਲ ਅਸੀਂ ਰੁਕ ਗਏ, ਲੇਕਿਨ ਸਾਡੀ ਉਹ ਸਾਊਂਡ ਉੱਥੇ ਘੁੰਮਦੀ ਰਹੇਗੀ ਰਿਫਲੈਕਸ਼ਨ ਕਰਕੇ, ਜਿਹਦੇ ਕਰਕੇ ਇਕੋ ਸੁਣਾਈ ਦੇਣਗੀਆਂ। ਉਹ ਟਾਈਮ ਜੋ ਸੋਰਸ ਸਵਿਚ ਆਫ ਕਰਤਾ, ਜਿਹਨੇ ਟਾਈਮ 'ਚ ਉਹ ਸਾਊਂਡ ਪਹਿਲੀ ਸਾਊਂਡ ਇਨਆਡੀਬਲ ਹੋ ਗਈ, ਸਾਨੂੰ ਸੁਣਾਈ ਦੇਣੋਂ ਬੰਦ ਹੋ ਗਈ, ਉਸ ਟਾਈਮ ਨੂੰ ਅਸੀਂ ਰਿਵਰਬਰੇਸ਼ਨ ਟਾਈਮ ਕਹਿੰਦੇ। So time during which the sound becomes inaudible after the source is switched off. So this reverberation time is controlled by a Sabine formula, which is given by T60. This formula is known as T60. In other words, you can say that the time during which sound decays to 60 decibel, decays by 60 decibel from the original sound, then it will be controlled. That's why it's called T60. So its value is T60, or reverberation time is equal to 0.161 V upon A, where V is called volume of hall, A is called total absorbing area. Because we can control reverberation time by increasing the volume of the hall, but there is a limit to increase the volume of hall, and by decreasing volume of the hall we can decrease reverberation time, or by increasing absorbing area. So we can increase the absorbing area as large as possible, so to control the reverberation time. So to control the reverberation time, we use carpets on the floor to decrease the reverberation time. We use woodwork on the walls, we use carpets, we use fabric material, and all these things. We use some perfect absorbers, some perfect windows in a big auditorium to decrease the reverberation time, to control the reverberation time, that echo should become inaudible in a sufficient time, so that we can hear next echo or speech clearly. Okay. So then a range of frequency, a range of hearing for what is the audible range? for human. So audible range for human is 20 hertz to 20,000 hertz. Audible range of what? Sound. Audio range of sound for human is 20 hertz to 20,000 hertz. So we can hear sound whose frequency lies between these two, 20 to 20,000 hertz. So we cannot hear a frequency less than 20 hertz or more than 20,000 hertz. So this is frequency of audible range. If nu is less than 20 hertz, that sound is known as infrasonic. If it is greater than 20,000 hertz, it is known as ultrasonic. This ultrasonic sound has large applications. We know the ultrasound used by doctors to examine the patient, in sonography, to break kidney stone, we use ultrasound. To kill cancer cells, we use ultrasound. It is used for welding purpose also. It is used to measure depth of the sea. There is a instrument known as sonar, sound navigation detection ranging. So sonar is based upon principle of reflection and use ultrasonic waves. So there are so many applications used in industry, in medical science, and in research also. So we use ultrasound. And of course, there are some more definitions for sound. Quality of sound. So quality of sound depends upon quality of sound, pitch, and loudness. The three characteristics of sound. So loudness means the ability with which we can differentiate between loud sound and faint sound. इसके नाम loud sound आ रही है, music loud है, faint है. So वो quality सानू differentiate कर दी है. That is called loudness. It depends on intensity. More is the intensity, more is the loudness of the sound. So by controlling intensity, so we can control the loudness. Then pitch. Pitch depends on frequency, but degree of shrillness. कि आवाज कितनी तिखी है या डल है. So it depend करता है ਉਹਦੀ pitch ਤੇ, that is degree of shrillness ਤੇ और frequency ਤੇ. For example, pitch of woman voice is more than that of man's voice because it is natural. So that's why women are preferred as telephone operators because of their high pitch. So high pitch quality is good. It is sweet to the listener. That's why they are preferred. So quality of sound. Ability which enables us to differentiate, to distinguish in our friends talking outside without seeing them. अपने दोस्त बाहर बोल रहा होंगे, गल कर रहा होंगे, अपने को लगता है कौन बोल रहे, तो वो क्वालिटी अलग अलग है. The quality of sound depends on different tones, different hormones which are different for different persons. तो किसी दी sound किसी नाल मिलदी नहीं, quality of sound different है. So this is all about sound. I have given a brief description of the whole chapter.